Hello everyone, my name is Sojan Matthew and today I will be demonstrating MongoDB sharding as a part of my personal project. So sharding is a method for distributing data across multiple machines. MongoDB uses sharding to support deployments with large datasets and high throughput operations. MongoDB supports horizontal scaling through sharding. So coming to the architecture, I have the following architecture deployed on AWS. It consists of three components. One is the config server, which is deployed as a replica set of three nodes, and a sharded cluster with two shards and three nodes in each shard, and a mongoose which acts as a query router. The job of the query router is to process the query from the application layer and communicate with the config servers to figure out where the given piece of information is stored in the shard cluster. And the config server basically holds the metadata and stored in the config servers. Metadata stores the information about the location of the data chunks that are being sharded as per the given configuration. Coming to the instances, I have the 10 instances launched, three three nodes in shard 1, other nodes in shard 2, and a replica set of three nodes as a config server and a query router to distribute the query across the layers. And coming to the security groups, I have these following security groups ports, and I have the ports of 27010 from for Mongoose, which uses the default port of MongoDB, and for the sharding I have used the security group of where I have exposed the ports 27017 to 27019, which is the default ports of shard servers and config servers. Config server runs on 27019 and shard servers runs on 27018. So coming to the configuration, before launching the cluster, we have to do certain configuration to configure it as a sharded cluster. So we have to make necessary changes in the config file. When after launching the config servers, we edit the mongod.conf file and we edit the port as 27019 by uncomment the bind IP so to allow the internode communication, and my replica set is the config server, and the role that the config servers will play in this will be the config svr, which is the config server. And after making necessary changes, I will start the MongoD in the background using the following command. Now to enter the Mongo shell on the config server, we will execute mongo port 27019. Now after doing the following configuration, I have initiated the replica set with the following command. The name of the replica set will be config server, and the ID of the host will be the three replica nodes that I will be deploying as a replica set. So after doing so, let's enter the Mongo shell. So as you can see, this is my replica set for config servers. Now when I do rs.status, I can see the configuration details. So these are my member nodes with one primary and two secondary, and this is the name of the replica set config server. You can do the same from the other nodes as well. Yeah, this is the secondary node of the replica set. Okay, now let's configure the shard servers. So in order to configure the shard servers, we have to make necessary changes in the MongoDB.conf file. Here the default port will be 27018, and commenting the bind IP part to allow internode communication. And my replica set name will be shard1, and the other three nodes will be in shard2. And the cluster role of in this cluster of the servers will be shards svr. Okay, after the configuration, we will start the MongoDB process in the background using this command sudo mongodb config etc mongodb-conf. And after that, we will enter the Mongo shell using the command mongo port 27018 and initialize the replica set of shard1, which will contain these three nodes. Similarly, in the shard2, we'll initiate the replica set of with the other three nodes. And now we can see the configuration here. I have already done the configuration in the conf files. So now when I do the rs.status, we can see the member details. Yeah, so this is my shard1, which is the name of the replica set, and my three nodes, one primary and two secondary. Doing the same on the other nodes as well. Yeah, so this is the secondary node of the shard 1, and doing the same on the final node of the first shard. So we can see the members being configured. Now checking the status from the shard 2, I'll do a rs.status. So as we can see, the 3 nodes configured in the shard 2. Similarly, rs.status from the other 2 nodes as well. Yeah, so now we have configured the shard servers as well as the config servers. Now we have to configure the Mongoose instance, which acts as a query router. To do so, we have to again change the config file accordingly. In the config file, we have to add this line config.db, where we will be mapping the names of the config servers. Then start the Mongoose process in the background using the following command. Then initiate the Mongo shell using Mongo port 27017. When you do that, we have to add the shards in the specify the shard details using the sh.addShard command. So we will execute these two commands, where we will provide the name of the shard and the nodes in the shard 1, and similarly we'll provide the name of the shard 2 and the nodes in the shard 2. Now after successfully doing so, we can check the number of shards using the command. So let's do that. So yeah, we can see that I have 2 shards. In shard 1 I have 3 nodes, and in shard 2 I have 3 nodes as well, both in healthy state. Now I will be creating a database where I will be sharding the data and storing it into different shards. Now to shard the data, we have to use a shard key. The shard key determines the distribution of documents in a collection among the cluster shards. A shard key is either an indexed field or an indexed compound field that exists in every document in the collection. Now there are different sharding strategies which we can use to shard the data. One of these techniques is hash-based sharding, and the second is range sharding. Here I have used hash-based sharding, and it mainly creates a hashed index to partition data across your sharded cluster, and hash indexes compute the hash value of the single field as index value, and this value is used to shard the key. So now we've used hash-based sharding on the field first name. So in order to do that, I will execute the command sh.shardCollection, my database name, my collection name, the field, and the hashed keyword. Now this will split the data based on the hash value of the first name. So here I have used BIOS collection, and I have inserted some sample data. So now let's do a find on the collection. BIOS.find. Yeah, so as we can see, we have the records here. Now when we do a count of this, let's check the count. Yeah, so now we have 10 records in the collection. Now let's check the count on the shard. So it should be split evenly across the 2 shards. So first let us find the records there. So we have the records here. Now let's do the same on the shard 2 as well. Yeah, so now we have the records there. So let's do a count to find the total documents in the shard 1. Yeah, so this says that we have 5 records in the shard 1. So now we expect the shard 2 should also contain the other 5. Yeah, so we have 5 records in split evenly across 2 shards. So Now we can conclude that we have successfully sharded the collection BIOS and we have split the data evenly across the two shards. This concludes my demonstration for the sharding of MongoDB cluster. Thank you. So this is the second part of my demo where I implemented a inter-region VPC pairing. The main idea behind this is to provide a simple and cost-effective way to share resources between regions and to replicate data for geographic redundancy. So in order to do that, I have deployed a 5-node replica set of MongoDB with 3 nodes in the Oregon region and the other 2 nodes in the Northern Virginia region. Here are my 3 instances in the Oregon region, 1, 2, and 3, with the all in the private subnet, and the other 2 are in the Northern Virginia region, 4 and 5, all in the private subnet. The security groups are where I have exposed the ports 22 and 27017. Same thing in the other region as well, where I've exposed the ports 22 and 27017. Yeah, now I have, in order to allow the communication between the nodes in different regions, I have created a VPC peering connection. So this is my VPC peering connection where I have configured the two VPCs with the requester CIDR as 10.0.0.16 and the acceptor CIDR as 172.0.0.0/16. Now I modified the subnet mappings to provide the CIDR blocks of the VPCs. This is my first subnet, and here in the route tables I have given the CIDR block of the VPs in the Northern Virginia region, and same thing I have done in the other subnet as well. So this is my subnet in the Virginia region. Here in the route tables I have provided the CIDR block of the VPC in the Oregon region. So now I have established a connection between two VPCs. Now let's check the data there. So these are my 5 nodes there, 3 of them in the Oregon region and the other 2 in the Northern Virginia. Now let's do a rs.status to check the cluster status. Yeah, so we can see we have 5 nodes there, 2 of them with the IP 172.172. These 2 are in the Northern Virginia region, and the first 3 are in the Oregon region. Now I can do rs.status in the second region as well. Yeah, so we can see we have the nodes configured properly. Okay, so now let's try to insert some data and see if the data is getting replicated across the nodes in different regions. So I've created a DB called peering demo. Now I have some sample data inserted there beforehand. Yeah, so we have 2 documents right now in the collection. So we can do the same thing in the other node as well. Doing rs.slave okay to read the data from secondary. Then switching back to the DB. And let's do a find here. Yeah, so we can see that we have 2 documents in the collection. We can do the same thing in the other nodes as well. Yeah, so we have 2 documents in the collection right now. Now let's try to insert our data and see that I'll C colon 3, insert a new value. Yeah, so let's do a find operation there. Yeah, we have 3 documents right now. Now let's do a find in the other nodes as well. Yeah, so as we can see, the data is getting replicated properly. The same thing in the other nodes as well. Switching to DB. Sort of find here. Yeah, so we have the updated documents in the nodes. Yeah. Now I have successfully deployed a replica set of 5 nodes in 2 different regions, thus promoting high availability and fault tolerance. So this is my demonstration of cross-region VPC peering. Thank you.